Hey guys, it's Miss Muller, and today we're going to be looking at some of the problems from the Memory Jogger for this week. So it wasn't printed in your packet, but it should be posted on Google Classroom, so you can look for Memory Joggers week 4, and you will find this sheet online, just like we did before we started having school at home. So go ahead and pull this up and look at it, and we're going to go over the first day's questions. So if you look at number 1, it says, problem A says Bella has 7 straws. All of the straws are 9 inches long. If Bella tapes all of the straws end to end, how long will her new super straw be? So this problem, I have to put my brackets around the information that we learned. So we learned that Bella has 7 straws, and all of the straws are 9 inches long. So basically what she has is 7 straws. So 1, 2, 3, 4, 5, 6, 7. And they're all touching end to end like this. And each one of them is 9 inches long. So if I have 9 inches for each one of these, 9, 9, 9, 9, 9, 9, and 9, that's going to give me 9 times 7. So I know 9 times 5 equals 45. So if I add 9 more, that'll get me 9 times 6, which equals 54. And then if I add 9 more, I'll have 9 times 7, which is 63. So it's going to be 63. For the next problem, it says, what is the area of this shape? So for area, I know that I'm finding the inside, and I can use an array and find the length times the width. So area equals length times width. I can find that by counting the squares across the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 times 1, 2, 3, 4, 5. 9 times 5. 1, 2, 3, 4, 5. So 9 times 5 is going to give me an area of 45. So my equation would be 9 times 5 equals 45. And if you were to count all of these squares, you would have 5, 10, 15, 20, 25, 30, 35, 40, 45 on the inside of the shape. So it would have 45. Now if we look at problem C, it asks us to circle true or false for each statement below. Prove your answer by shading both fractions. So we're shading the fraction 1/2 because it's 1 over 2, and then 2/4 because it's 2 out of 4. So for 1/2, I shade 1 piece out of the 2. And then for 2/4, I shade 2 pieces out of the 4. If I look at these two shapes, the same amount is shaded on both sides. Half is shaded here, and half of the shape is shaded here. If I were to just make it 2 pieces, I would have 1 piece that was shaded and 1 that was not. So this is true. 1/2 does equal 2/4. If I look at this next one, I have 3/3 equals 3. So 3/3, I have 1 whole divided into 3 pieces, and I'm shading 3 of them. And so we know when the numerator and the denominator are the same, that equals 1 whole. So 3/3 equals 1 whole. 3 is 3 wholes. So I would have to have this 1 whole plus 2 more wholes to equal 3. So this is equal to just 1 whole. In order for this side to look like that, I would have to shade just this 1 whole, 2 wholes, 3 wholes. So this is 3 wholes, and this is only 1 whole. So it is false. This 1 does not equal 3. If I look at this next one, it has 4 over 1. So that means that I have a bigger numerator than denominator, so the fraction is going to be bigger than 1. It's going to be each whole is going to be broken up into only 1 part. So if I take my first whole and break it into 1 part and color it, that's going to give me 1 out of 1. or 1 whole. This next one is going to give me 2 over 1, which is 2 wholes. Here would be 3 over 1, which is 3 wholes. And here would be 4 over 1, which is 4 wholes. Over here I have 4 wholes. So I have 1, 2, 3, 4. 4 holes. So 4 holes on this side and 4 holes on this side. That is true. They are equal. Problem D says, how is the multiple in the 8 column related to the multiple in the 4 column for each row? Are any other columns related the same way? So I'm looking at the 4 column and the 8 column. And the best way is to look and pick one number in the chart and look all the way across and see what the multiple is for 4 and the multiple is for 8. So here I have 1 times 4 is 4 and 1 times 8 equals 8. So I have 4 and 8. And I want to figure out how these two numbers are related. So I know that 4 plus 4 equals 8, or 4 times 2 equals 8. Then if I look at the next column, I have 2 times 4 is 8, and 2 times 8 is 16. I have 8 over here and 16. How are those two numbers related? Well, 8 times 2 equals 16. If I look at the next row, it's the same thing, 12 and 24. And I know 12 times 2 equals 24, all the way down to the last column where 4 times 10 is 40 and 8 times 10 is 80. And 40 times 2 equals 80. So what I notice is that the columns are related by the multiples of 4 doubled give me the multiples of 8. So I'll write that down. The multiples of 4 doubled, which means times 2, equals the multiples of 8. And for what other columns does this work? So I'm looking for other columns that I could double to get the next column. So let's look at these first two. If I take the first column 1 and I double it, do I get the correct answer? 1 times 2 equals 2. 2 times 2 equals 4. 3 times 2 equals 6. So that's correct. 1 and 2 work this way. What about 2 and 4? So I can have, look at the 2 column and the 4 column. 2 times 2 equals 4. 4 times 2 equals 8. 6 times 2 equals 12. 8 times 2 equals 16. So yes, 2 and 4 work that way. Next, 3. If I double 3, I need to look at 6, the multiples of 6. So 3 and 6, let's check to make sure it works. 3 times 2 equals 6. 6 times 2 equals 12. 9 times 2 equals 18. 12 times 2 equals 24, so that's correct. And then we already did 4 and 8. So now we have to look at 5 times 2, which is 10, and see if that works. 5 times 2 equals 10. 10 times 2 equals 20. 15 times 2 equals 30. 20 times 2 equals 40, so that one also works. It's 5 and 10. If I wanted to look at my next number, 6, if I doubled 6, it would be 12, which is not on this chart. So that's all that we can find on this hundreds chart. When you're looking at the next day's problems and looking at problem D again, you're looking at the multiples of 2 and 4. So they put a red dot on multiples of 2, so you can find a way to mark down or just write down all the multiples of 2, and a blue dot on the multiples of 4, so write down all the multiples of 4, and then you're going to find out what they have in common. So we already talked about how 2 and 4 are one of those special pairs that can be doubled, but there are other ways that they are related too. So go ahead and take a look at that. I'll be posting the answer keys at the end of the week, so keep looking for a video on that. Have a great night, and I will see you soon. Bye.